Alright, we're back with this pulley problem as problem number 4 from Physics 111 and Practice Exam 2. And what we're going to do is we're going to go ahead and write out our sum of forces. Let's go ahead and start with M2 because it only has one axis of forces. So the sum of forces in the y direction is equal to ma, right? Mass 2 is the mass of this object times the acceleration that we're looking for. Now we just need to sum the forces. So I like to keep my positive directions. I like to stay with the mathematical convention that up is positive and right is positive. So sticking with that convention, tension's going up, and M2G is going down. So T minus M2G is equal to M2A. Alright, so now that we're there, I would just like to point out that the acceleration that we decided this system was going to have based on which external force was winning, either M2G, turns out the force in the x direction is beating the M2G downwards, so the acceleration is going this way. Now the acceleration is upwards, which by our convention is positive, and so that's why the acceleration here is written as a positive. If we were accelerating downwards, I would write this as a negative. So now let's do our sum of forces in the y for M1. That's going to equal M1 times the acceleration, which remember these are going, well actually, in the y direction, this is resting on the table. So we know that this block is not moving up or moving down, it's moving to the left. And so therefore the acceleration is 0, and so we're dealing with a static system. Now if we sum the forces in the y, upwards we have F sine of 30 degrees, and we know our force is 40 newtons. I'm going to go ahead and write that in. 40 newtons times sine 30. Then we're going to add the normal force, and then we're going to subtract M1G. And this is going to equal 0 because this is a static system in the y direction. So let's go ahead and plug in some numbers. M1 is 4 kg times 9.8, which is g. So for this term we get minus 39.2. Normal force we don't know. Sine 30 times 40 is 20. So we know that 20 plus the normal force minus 39.2 equals 0. So to solve for the normal force, we'll add the 39.2 over, and then subtract the 20 over. And that's going to give us a normal force of 19.2 newtons. Alright, so that's about all we can learn from the sum of forces in the y. And because there's no friction, it's frictionless, we don't really need to know the normal force, but that's just a good process to get in the habit of, because if there was friction, we would need to know what the normal force is. But in this problem, the sum of forces in the y is not important to the answer. So we'll start with sum of forces on the x equals M1A. Now once the A here is going to be equal to the A there in magnitude, because both of those accelerations are going to be the same in the system, as long as there's no slack in the rope, or the rope isn't allowed to extend or contract. So now we're looking at sum of forces in the x, positives to the right, so we have tension to the right, minus F, which is 40 newtons times cosine 30, equals MA. Now you'll notice the A here is going in the negative direction for our frame of reference. So I'm going to write m and then negative a to indicate that my acceleration is going to the left. Alright, so now that we know that, let's go ahead. Oh, and this is m1, I'm sorry. This is m1. So we have two equations and several unknowns. Let's go ahead and plug in the numbers we do know. So over here we have tension, which we don't know, minus m2g. m2 is 2 kg times 9.8. That gives us 19.6 is equal to m2 times a. Well, we don't know a, but we do know that m2 is 2. So here's one equation with two unknowns. Let's go ahead and plug in what's on this side. This term right here turns into minus 34.64 roughly. So tension minus 34.64 is equal to m1 is 4 kg. So we have minus 4a, bringing that negative outside. So we have two equations, two unknowns. At this point, I'm going to free up some room with my free body diagram, because now it's all going to be algebra. Alright, so we could use elimination or we could use substitution. We're solving for acceleration, so I'm going to go ahead and use elimination. What I'm going to do is I'm going to set up this equation. I'm going to write it underneath this equation, and I want to cancel my t's because I want to solve for my a's. So to do that, I'm going to have to factor in a negative to every term here. And so when I factor that in, I'm going to get a negative t, a positive 34.64, and a positive 4.8. So now that we know that, we can now add these two terms together. T minus t is 0. Negative 19.6 plus 34.64 is a positive 15.04. And a 2 plus a 4a is equal to 6a. Alright, so now we can go ahead and divide 6 from both sides. And 15.04 divided by 6. That gives us that the acceleration is roughly equal to 2.51 meters per second squared. And because that is the acceleration for both this block and that block, we have now officially answered the question that said, what is the magnitude of the acceleration of the suspended object? All surfaces are frictionless. So this is the end of the problem. This is one of the more challenging styles of problems. It's very important to have sort of a methodical approach to it. Everybody has a different approach, but take the methods that you like, that you saw me use, make up some of your own methods that help you keep things organized and in track. And I'll see you next time.